and conditionally convergent, absolutely convergent, and alternating series. These three concepts are together we are going to discuss. So Leibniz test is what? An alternating series of the form summation n is equals to 1 to infinity minus 1 whole power n minus 1. How the alternating series will be, you see, the first term will be there, positive. The second term will be negative. Again, the third term will be positive. And the next term will be negative. And it is continuing, plus and so on. So any series of this format is said to be alternating series. I'll give you another definition if you want. So a series whose terms are alternatively positive and negative is called an alternating series. So this is an alternating series. Now we are going to check whether this alternating series is convergent or divergent. So we have the only test which is called Leibniz test or Leibniz test. This is the test we are using to check an alternating series convergent or divergent. So there are two conditions to check it. The number one, condition number one. Okay. This one I am writing in words. Each term is numerically less than the preceding term. Numerically.
There is no PDF for this test.
Yes, is there. I will send it to you after the class.
Okay.
Numerically less than preceding term. And that is actually the mathematical meaning of this is un is strictly un plus 1 strictly less than un for all values of n. This is the condition number one. The second condition is if you take limit n tends to infinity, this one limit n tends to infinite, un value must be equal to 0. If any alternating series satisfying these two conditions by Leibniz test, we can say that it is convergent. So if you want to see the example, though the example is for this one is, this is the example. The best example, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus and so on. So can we say it is an alternating series?
Yes, because minus.
Yes, minus plus. And you see, every next term will be numerically less than the every succeeding term is numerically less than the preceding term. It means you see the value of 1 by 2. 1 by 2 is 0.5 and 1 by 3 is 0.3. This is 0. Something 0.2 like that. So every next term, every coming term is numerically less than the previous term, irrespective of sign.
Okay.
Irrespective of sign. So this is the best example. Now after this one.
So can the series be plus plus also while the next term is?
No, it should be all terms are alternately positive and negative only.
Okay.
Alternately positive and negative. Then only we can say that it is an alternating. ऐसा नहीं हो सकता. It should be minus plus. Then remaining all the terms are positive. It should not be like that. Okay. There are some positive terms and negative terms alternatively. Okay. So to understand this concept, better to go for this example only. We are going to check whether this particular series is convergent or divergent. So let me do this question only. Test the convergence of this one 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus and so on. today, inshallah, we are going to finish it. This one, alternating series concept and unit number 1. If possible,
Okay.
I will take one more class, but I want to finish it today only.
Okay.
So let us check it. Starting the solution. What we have to do it, we have to find out its nth term, un value first of all. So the nth term is, can you tell me how we are going to frame the nth term? Un is equal to, you see, if it is alternately positive and negative, now better to write start like this, -1 whole to the power of n minus 1. Then you can see the numerator is 1 1 1 1, so 1. Denominator is starting with 1 2 3, so definitely 1 by n is n. Let me check whether it is correct or not. If you put n is equal to 1, 1 minus 1, 0, any number power is 0 is 1, 1 by 1. That means we are getting absolutely the first term. Now, if you put n is equal to 2, minus 1 whole power 2 minus 1 means term is negative 1 by 2. So, yes, it is negative. Next, like that, it is continuing, so that we can say it is, yes, definitely nth term is accurate. Now, let us compare with the standard form. I am comparing with the standard form. That is, here also it is summation value. And here also we should write, okay, we'll do one thing. We should write this one in summation form, first of all. This one. This is like that, summation n is equals to 1 to infinity. Now it is perfect. This one we are comparing with the standard form. Summation n is equals to 1 to infinity. We are comparing with the standard form, that is -1 whole power n minus 1 into un. This is the standard form of any alternating series. You can see here also I wrote in this, yes, here you see. This is the standard form, right? Okay. So let us continue. Hello? Okay. So if you compare with the standard form, tell me what is our un value?
-1.
1 by n only, -1 whole power n minus 1, -1 whole power n minus 1. Summation also cancelling on both sides.
Cancelling. Okay.
And un plus 1 value. What is un plus 1 becomes? 1 by n plus 1.
N plus 1.
1 by n plus 1. So it is becomes, what it is becomes now?
We have to do the ratio to save.
Yes, no, ratio not. This is satisfying both of the conditions. Okay.
Okay.
This one, un value, un plus 1 value is less than un. I will give you the example. Suppose, for example, suppose n is equal to 5. N is equal to 5 means what is un becomes 1 by 5, right? 1 by 5 means 0.2. Clear now? 1 by 5 means 0.2. And un plus 1. Un plus 1 is equal to 1 by 5 plus 1 means 1 by 6. Now you can see this is 1 by 6 is 0.16, something like that. So definitely 0.16 should be strictly less than 0.2. It means un plus 1 is less than un plus 1 for all values of. It is not compulsory to take n is equal to 5 only. You can take any values of n, it is satisfied. Now, second condition we have to check, that is limit n tends to infinity, un value, which is equal to limit n tends to infinity, the value of un is 1 by n. As we know that as n tends to infinity, definitely 1 by n becomes 0. So this above series satisfying both of the conditions of Leibniz test. So therefore, by Leibniz test, by Leibniz test, given series convergent. Given series, you will get 2 marks question only, okay? Given
Okay.
series
Okay.
convergent. This topic is only for 2 marks. You should not get
2
any
marks. Okay.
LAQ from here. LAQ possibilities,
Okay.
Rabi test, logarithmic test, and ratio test. Only 3 possibilities are there. So this is the first question we have completed. Let me discuss one more question.
So you said this is the last topic, but absolutely
Definitely, this is the
convergent
last topic. Absolutely convergent, conditionally convergent will also come under this only.
Okay.
Under this topic only. That is also the discussion of this only.
Even that is for 2 marks.
Yes, that is also for 2 marks. Same concept continuing. See, one more question which is given last year. There are 2 bits in this question. Let me discuss that question. And moreover, here only the PDF of this question is also there. I will send it to you later on after this class. This question is not this one, I think. No, yes, it's not here. So let me do it. It is not here. It's a different question. Let me do it here. So here now I will write the definition of conditionally convergent and absolutely convergent. See here. First of all, absolutely convergent. Absolutely convergent. A simple definition which is asking in the last year question paper in 2021. Define absolute convergent and conditional convergent. So simple definition, if summation un convergent and summation mod un is also convergent, summation un convergent and summation mod un also convergent, then the series convergent absolutely, then the series convergent absolutely. So means nth term will be convergent, and if you take the modulus of nth term, that is also becomes convergent, then we say that the given series convergent absolutely. This is a quite opposite definition, conditionally convergent.
The opposite of this is?
Opposite means how?
Is summation un is divergent?
No, summation un convergent, but summation mod un divergent.
Okay.
If these 2 lines only you have to write, it is given last year 2021 question paper number 1. Question number 1 is this only. Summation un convergent, but
summation mod un is divergent.
Mod un summation, this is not like that, this is not there. Summation mod un divergent, then the series convergent conditionally, then the series convergent conditionally. And one more facility is available here for this concept. In the question only it is going to be mentioned that test whether the following series is conditionally convergent or absolutely convergent.
Okay.
क्वेश्चन में आपको मेंशन करेगा रहता है कि भाई आप किसे करना है, कंडीशनली कन्वर्जेंट और एब्सोल्युटली कन्वर्जेंट. ठीक है. Then I'll go for the next page. कुछ ले रहा नहीं। Okay. The question, how the question will come, you see here, question paper also. The questions, it is a facility, suppose you can see, the question is like this: test the following series for, it is clearly mentioned here, conditionally convergent, or it's given as a slash, or absolutely convergent. Absolutely convergent. So now you can see the solution. Okay, question. So the bit number 1 is here. Bit number 1 is summation -1 to the power of n 1 by n. This is the bit number 1. And let me do one more bit, that is summation -1 to the power of n minus 1 1 by n minus 1. Okay. So before start writing the solution of these two, what I want to tell you, actually you should know what is alternating series and what is Leibniz test. Then only we can do these problems, absolutely convergent and conditionally convergent problems.
Yeah.
So that you see the previous page and you see what is the definition of absolutely convergent and conditionally convergent definition. You see, summation un convergent and summation mod un also convergent. What do you mean by un, summation un?
Some nth term.
Very good, excellent. Nth term of the given series. That
Given
should be
series.
convergent. Okay, that should be convergent. And summation mod un also. What is the meaning of this? Instead of giving a series of positive terms, in these two cases, always alternating series is given here. Okay.
Okay.
And to check whether alternating series convergent or not, we have the only facility that is called Leibniz test. Leibniz test is the only test we are going to use it to check the alternating series convergent or divergent. Okay. And here divergent, this word I'm not using for Leibniz test. If it's satisfying both of the condition, like a previous example, then we say that it is convergent, otherwise it is not convergent. Do you understand? Convergent hota ya nahi hota, divergent nahi. This example, if you see, in this example, it is satisfying both of the conditions. Suppose at least one condition is failed, we say that it is not convergent. Do you understand? Hello? 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 Can you hear me, Hassan? Hello? Hello.
Yeah, yes, sir. Sorry, internet issue.
So let me
Hello.
start writing the solution of these two problems.
Yeah, yeah.
Now, what is bit number 1? Summation -1 whole to the power of n 1 by n. It indicates
Yeah,
that it's a nth term and alternating series.
yeah.
Hello. Yes.
Yeah, yes, sir.
Okay. So nth term
Hello.
and alternating series. Let me start writing the solution.
Yes, sir.
Okay, see here. See here, solution. The solution. Summation -1 to the power of n 1 by n. This we are going to compare with our standard form. Okay. That is okay. Summation value means which value is this? Summation value means what do you say? Which value? Un value, no?
Yeah, yeah.
Un value is equal to what is that? -1 whole power n -1 whole power n. I'm sorry, here it is root 1 by n is there, not like that. It is root 1 by n. Question में थोड़ा सा correction करिए. It is 1 by, it's not 1 by n. It is root 1 by n. So it is 1 by root n. It is also 1 by root n. It is also 1 by root n. Okay. So -1 whole power n and 1 by root n. This is -1 whole power n and 1 by root n. So what we will do it here, let me find out its modulus value. अच्छा देखें यहाँ पे ये भी चीज बताना जरूरी है. Yes, this one. Summation un convergent, summation mod. It's not compulsory to check. पहले un check करना है, बाद में mod un check करना है. It is not compulsory. आप पहले mod un भी check कर सकते हैं. Choice is yours.
Okay.
That condition, if दोनों condition को check करना है. Simultaneously, it is not compulsory. Right?
Okay.
Summation mod un.
Mod UN. Yeah.
Summation mod un is nothing but summation of
1 by root n.
modulus value of this one -1 whole power n into 1 by root n.
Yeah.
1 by root n. So if I'm comparing, under the modulus, negative value will become positive only, no?
Positive, yeah.
Yes, summation mod un value means both are same. Summation mod un both are same. It becomes, if under the modulus, you will get the answer is 1 by root n only.
Root n,
Minus value will become positive, right? This can I write
Yes.
also, can we write like this? N to the power of 1 by 2.
1 by 2, yeah.
So we have a facility, helping test, remember? 1 by n power p test.
Yeah, p test. Yeah.
So if you compare, what is p value?
1 by 2.
1 by 2 definitely less than 1.
Yes.
So by p test, summation mod un, what do you say? By p test. By p test,
Yes.
summation mod un less than or equal to क्या है? Summation mod
Less than
un
or equal to divergent है.
So it is divergence. So summation mod un value, we got it as divergence. Okay. Let me check it un value.
Okay.
Let me check it un value. So there un value is, here we have un is equals to 1 by root n. Un is equals to 1 by root n. And un plus 1 equals to
Here this
n
one
plus
is equal
1
to 1
equals
by root n plus 1.
1 by root n plus 1.
N plus 1, yeah.
1 by root n plus 1. Right? So
Yes.
definitely we can say that un plus 1 value, un plus 1 value is less than un for all n.
Yeah.
Do you want the example? Let us take the example. If n value is 3, for example, then 1 by root 3 value.
1 by root 3.
Do you have a calculator? Check it and tell me. 1 by root 3 plus 1 is 4. 1 by root 4. Root 4 is 2. 1 by 2 is 0.5. What about 1 by root 3 becomes?
1 second. 0.577.
0.57.
Yeah.
0.57 means 0.57. I think accurate value लेने के लिए okay n is equal to 3 से भी आ रहा. And what about 1 by 2 becomes
1 by 2 is 0.5.
0.
1 by root 2.
Oh yes, I'm sorry, I forget that.
Yeah.
Root 2, why root 2? 4, 3 plus 1, 4. 1 by 4.
3 plus 1 4, no? So 1 by root 4 we have to take it.
Oh, root 4 is 2 only, no?
Root 4 is 2. So 1 by 2 is 0.5.
This is 0.
That was 0.577. But I didn't do it in scientific calculator. So
Okay, let us forget about it, no problem at all. This one you will get it because it is a 2 marks question that we need not to worry about it. If you want to check it, don't go for a smallest value, take some big value, then only you will get it easily. Okay.
So
then limit n tends to infinity un is equals to limit n tends to infinity 1 by root n. 1 by root n, n can be written as 1 to the 4 like this also. But we know that as n tends to infinity, 1 by n tends to 0. Power may be anything. So by Leibniz test, by Leibniz test, summation un convergent. So previously we proved summation mod un divergent and summation un convergent. So which condition is satisfied here? We write here. Therefore,
this will be the first condition. Huh?
Yes. Therefore, I want to write in words summation.
Okay.
Summation un convergent. But
and summation mod un
but
divergent.
Summation mod un divergent. Then therefore given series बोलिए
conditionally convergent.
Therefore given series conditionally convergent. Given series convergent conditionally or conditionally convergent. Both are same meaning. Convergent conditionally. So like that we have to do, and this is the only 2 marks. You should not get any long answer for this topic. You will get a small questions only. Okay, na?
Okay, sir.
Okay. So let us do it one more question. The second bit of this one, summation -1 whole power n minus 1 by. Here also by mistake I wrote the wrong question. So let me correct.
Is it root n minus 1?
No, it's n square plus 1. Actually, I am going to trial this another format, like how to write in word format. Word format में online कैसा लिख सकते एक बार experiment कर रहा हूँ मैं, इसीलिए थोड़ा गलतियां हो जा रही. Normally I used to go for that board only, Zoom board. That is comfortable for me, but this is I am trial method.
Okay.
That's what some mistakes is there. The second bit is the question is summation -1 whole to the power of n minus 1 minus 1 whole to the power of n minus 1, 1 by n square plus 1, 1 by n square plus 1. Okay, so solution. Solution. Okay, summation value is nothing but it's our un value. Un is equals to minus 1 to the power of n minus 1, 1 by n square plus 1, 1 by n square plus 1. So let me go for summation mod un value. Summation mod
The
un value.
negative term will
It
become
means
positive.
whenever we are taking modulus, let me write modulus also, minus 1 to the power of n minus 1, 1 by n square plus 1. Now if you take modulus, and you know that whenever we are taking modulus, even minus sign will also becomes plus only. So mod un value is 1 by n square plus 1. Is that clear?
Yeah.
Yes. Now, if you notice, if you remember, it is a proper fraction.
Yes. Because the degree
Is a
of
proper
denominator
fraction.
is greater.
Yes. So which test?
Mhm.
Which test? Here you see, here also we are come across this situation, but directly we applied p test and we got the answer. But here the situation is little different. Understood?
Yeah.
So that means proper fraction, which test? Come on, you can do it. That is limit comparison test.
Limit comparison. Okay.
Highest power of n from numerator, nothing is there. Denominator highest power is 1 by n square. Clear?
Yes, sir.
Okay, I'll go to the
Yes,
next
sir.
page. Okay, so Vn value is 1 by n square, and you know the process of limit comparison test, that is limit n tends to infinity. Okay, modulus of un value. We don't have un, we have modulus of un. That is the only difference. Remember, is equals to limit n tends to infinite. Okay,
1 by
we're
n
doing the
square
same
plus
limit
1.
comparison test only, but instead of un,
Yeah,
we
yeah.
have mod un.
Mod
That
un.
is the only difference. So let me take
Yeah.
n square common also, because you know the process already, limit comparison test.
1 plus.
Directly I'm taking n square common also, and second fraction will become reverse, that is n square by
Yes,
1.
n
By
square
1 no
plus
need to write, n square and n square cancel.
cancel.
AL stands for
Yeah.
applying the limit. Our answer is 1, that is a finite value.
1. Yes.
So finite value means we can say by statement you have to write. What is the statement? By
Limit comparison.
limit comparison test, summation un
Un.
and summation vn behave same, behave same, but summation vn equals to what is that? 1 by n square. 1 by n square. We are going to compare with
Helping test.
one. Yes, helping test,
P
that is
test.
1 by n power p.
Yeah.
Okay, na?
N is equal to 2.
Then
Yeah.
definitely, if you compare, we are getting p value is equals to 2, that is greater than 1.
Yeah.
Okay, और यहाँ पे
Convergent.
we forget to write modulus here, right?
Mhm.
So therefore summation
By p test.
yes by p test by p test summation vn convergent. It
Yeah.
means that this implies that summation
UN is
mod
also
un also convergent.
convergent. Yeah.
Summation mod un also
Convergent.
convergent. अच्छा देखिए प्रीवियस क्वेश्चन में डाइवर्जेंट था तो अपन डायरेक्टली फिर से कन्वर्जेंट चेक करें. यहाँ पे मैं एक नोट लिख देता हूँ. आई विल राइट व्हेन ऐड हियर वन नोट पॉइंट. note if summation mod un is convergent. So example is of suppose a student is in engineering, it means he already passed 10th class now.
Yes, sir.
This is the best example. If summation mod un is convergent, then un is also convergent.
Yeah.
So that means it is the example of then series convergent absolutely. अगर आपको divergent आ रहा, then only we have to go for another case. In the first step only, if mod un is convergent, then no need to check. Understood?
Yes, sir.
This is a note to understand that point. There's no problem also we did. So already we proved summation mod un is convergent. It means directly we checked whether the student is in engineering. So we proved that he is in engineering. It means he already passed 10th class. Therefore, Walaikum Salam. Therefore, the series summation -1 to the power of n minus 1 by n square plus 1 n square plus 1 is absolutely convergent. Clear now?
Yes, sir.
Absolutely convergent.
Convergent.
This is the end of this problem. Okay, I am sending this PDF also. You check this PDF, and if you want, let us do it one more session today only.
Okay, sir.
Okay, I am sending this PDF because we don't have the time. I will stop it this class, and if you want,
Yeah.
I will arrange one other class. Okay.
Okay. Okay.
Right.
I'll go through the PDF.
Yes, I'm sending you some other questions also there in this PDF.